Hello friends, welcome to TechCube Gate classes. My name is Professor Vivek Singh Rathore and I am teaching Signals and Systems subject through this video lectures. I have taken two video lectures and in that I have completed almost the elementary signals like unit step, unit ramp, unit impulse, and what are the operations which can be performed on these signal like time shifting, time scaling, time reversal. Okay, these operations I have performed and how we can mathematically and graphically represent any signal. Now in today's lecture we will be dealing with what are the operations like time shifting, time scaling and all which can be performed on these basic elementary signal and what are the effects on these signal that will be today we'll be dealing with. And okay, so let's start with the session and we'll also deal with some of the numerical questions to for better understanding of these concepts. Okay, so let's start and our first topic and first question will be, or the first concept will be, what are the effect of time shifting on unit step and how we can represent any signal in terms of unit step signal. So see, this signal you already know unit step signal is at t is equal to 0 there is a step change. Okay, at t is equal to 0, so this signal can be represented as ut minus 0 or generally you represent as ut. If I tell you that just plot ut minus 1, then you will be plotting like this. Ut minus 1 means at t is equal to t minus 1, if you equate equal to 0 you will get t is equal to 1. So at t is equal to 1 you will get a step change. Okay, step change of unit magnitude, because here the magnitude is 1, so that's why the step change will be ut minus 1. If there will be a step change of 2 ut minus 1, I will be telling you that this step is 2. Okay, so this is there and this is t is equal to minus 1. Now I think you have understood what are the how we can do time shifting operations on ut minus 1 ut. Now if I tell you just plot it ut plus 1, then you will tell, okay sir, this is at t is equal to minus 1, there is a step change and there is a step change of like this and it will go on. But can you tell me it is a finite signal or infinite signal? Means is it the time duration is finite? So you will tell, no sir, it is going on till infinite. It is going on till infinite, this is infinite duration signal. But if I tell you that just plot ut plus 1 and plus ut minus 1, then what you will do? You will do just, I think will plot here ut plus 1 plus ut minus 1, and next I will plot you ut plus 1 minus ut minus 1. You can understand what basic thing I want to tell you. This is our t is equal to 0. Okay, so ut plus 1, if you see at t is equal to minus 1 there is a step change. Okay, t is equal to minus 1 and this will go on up till when it will go on? Till ut minus 1, means t minus 1 is equal to 0, so t is equal to 1 and there is a step change. How much step change? Plus 1. So we will go plus 1 step change and again it will go. So this will go on. This is again an infinite duration signal. Now if you plot this signal, then what will happen? See, this is our plot and t is equal to 0, t minus ut at t is equal to minus 1 there is a step change of 1, so it will go on and there is a step change at t is equal to 1 also. So t is equal to 1, t is equal to minus 1, there is a step change and how much step change? There is a minus 1 step change, so it will be like this. This is called as finite duration signal, or you better call it as a rectangular pulse or gate pulse, but whatever it may be, you need to call it as finite duration signal because it is a finite duration. But if in this question if I tell you just do it as minus 2, then you will tell, okay sir, this signal is going on till from here and it is going on this side, and then there is a step change of minus 2. So one step change up till here and second step change up till here, and then it will go on like this. Now again it becomes infinite duration signal. So for finite duration signal there must be this amplitude, and all amplitude of unit step signal, if you add all amplitude you should get final value as 0. earlier there was +1, there was -1, so it was coming 0. That's why you have seen this signal as finite duration. But now 0 minus 2 is sorry 1 minus 2 is -1. That is why it is an infinite duration. Here also 1 plus 1 is 2, so it is an infinite duration signal. So whenever if you want to see a finite duration signal for a unit step signals, so you need to see the amplitude, addition of amplitude should become 0. Okay, so I think this question you have understood. Now I will tell you how to see this question. From this question you have understood that how to represent any signal, or if you if I'll give you expression of unit step, you can plot it like this. But if I give you direct plot, can you write it in unit step signal? So let's see. First I'll give you this plot, and there is a graph like this, and this is there, and this is there, this, okay, this, okay. So this is amplitude 1, this is amplitude I think we'll say it as -2, okay, and this is time duration -1, 0, 1, 2 and 3. Now if I tell you ki just represent in unit step, so what you will going to do? So let's see. See, there is a step change at t is equal to -1. So, and how much step change? One step change. So 1 ut of to t plus 1, okay, and then it will go on, go on. There is again step change of at t is equal to 0. So -1 ut minus 0. Then I'll tell you this will go on, and again there is a step change of 1 ut minus 1, and there is a step change, I think how much step change? +1 and -2. I think -3 step change will be there, -3 step change will be there at t is equal to -2, okay, t is equal to t2. And then again there is a step change of -2, so there will be I think +2 ut of -3. This is the mathematical representation of this type of signal. If you want to see it is a finite signal or infinite signal, finite duration signal, you can see +1 -1 0, +1 +2 +3, and -3 is equal to 0. So ultimately amplitude is coming, the sum of amplitude is coming 0. That is means it is a finite time duration signal. This you can understand. Now we will see what is the effect of time shifting operations on ramp signal. So see, effect of ramp signal already you should know, and I have told you also that ramp signal is nothing but a step change or a change of slope at whichever point you need. So unit ramp means, if you say unit ramp means slope will be unit, change of slope will be unit, and ramp means just increase of slope. So here if you say at rt, if you say, then you can plot it like this. At t is equal to 0 there is a change of slope, and how much slope change is there? 1 unit is slope change is there. If you see, if I tell you rt -2, then how you can plot it? This is the signal, this is the axis, and then I think rt -2 means t -2 equal to 0, so t is equal to 2. There will be a step change of unit slope. So at t is equal to t is equal to 2, so there will be like this signal, and this there will be a slope change at t is equal to 2. So this is called as rt -2. Same as rt plus 1 also you can plot it, just you need to shift at t is equal to -1. Now the second part is that if I give you a signal, can you represent in ramp signal? So let's see if you can do it. So I'll give you a question is I'll give you a triangular pulse, okay. Triangular pulse is there. This is a triangular pulse because it has a change of slope. That's why I'm giving you this question. And let's suppose this value is -2 to 2, okay, and the value is here I think 4. We can take it as 4. Now the question is, can you represent it as in the terms of rt, that is ramp signal? So how we can do it? See, first the signal is dc value, nothing, 0 values are going on. Suddenly there is a change of slope. How much slope? First we need to calculate the slope value. So slope value you can calculate it as see mt plus c, from there also ft is equal to mt plus c, also you can do it mt plus c. But what is the slope here? Slope, y2 minus y1 by x2 minus x1, m is equal to 4 minus 0 and 0 of minus 2. So you'll get 4 by 2, that is 2. So you'll get here plus 2 slope change. Okay, same if you can do here, you'll get minus 2 slope change. So let's see, there is a slope change. What is the change of slope? You can do final value minus initial value. So final value was 2 and initial value was 0, so there is a slope change of 2. Okay, so and positive, in positive direction, so you'll take as plus 2 magnitude, and r you'll take at which point t is equal to minus 2, so you'll take as 2 plus 2, t plus 2. When you'll equate it with 0, you'll get t is equal to minus 2. Okay, now what we'll do, so this will go on, go on. Suddenly at t is equal to 0, t is equal to 0, there is a slope change. How much slope change? You'll take final value minus initial value minus 2, and minus of 2 is equal to minus 4. So there will be slope change of minus 4, and r will be there at which point t is equal to 0. So t minus 0 you can take it, and then suddenly it will go and go and go, and suddenly the slope again changes at t is equal to 2. So how much slope change? See, final value is, final slope is 0, initial slope is minus 2. So 0 minus minus 2 means plus 2. So 2 r t minus 2. So this upper, that triangular pulse, can be represent it as a series sum of some ramp signals. This you can represent it as. Okay, so many signals are there. If you see a trapezoidal signal, if I say you a trapezoidal signal, see, mixture of signals are there. Here if you see trapezoidal signal, you see, let minus 4, minus 2, 2 and 4, and the magnitude is, let's suppose 1. Now let's suppose magnitude is, I think, 4 only. Okay, no problem. So see, um, this signal, trapezoidal signal, consists of unit ramp also, or and DC values are also. Okay, so let's see how we can plot it. If you want to plot it, first you see from in minus infinite, it will come at t is equal to minus 4. We have a slope change. How much slope? First we need to calculate slope. So this value is 4 minus y2 minus y1, 4 minus 0, and this value is minus 2 and minus of minus 4. So you'll get 4 minus 2 plus 4, so you'll get 4 by 2, so you'll get 2. So this slope is equal to plus 2. Same here also you'll get minus 2 slope, and this value is all 0 only, because this is DC value. So now how we can represent it? So see, first of all we'll do where is slope change at rt minus 4. So we'll write as rt plus 4. T is equal to minus 4, there is a slope change. Okay, and then how much slope change will be there? So final value minus initial value, final slope is 2 and initial slope is 0, so 2 minus 0 is 2. So there is a plus 2 slope change is there. Okay, now we can write this. So this, up till this portion it has gone, and it is going on only. Okay, but we need to stop at minus 2. There is a slope change. Actually now slope is 0, and earlier slope was 2, so there is a slope change. So we need to write at r t plus 2, there is a slope change. How much slope change? 0 minus 2 is minus 2, so there is a minus 2 slope change at t is equal to minus 2. Now it will go on like this, like this, like this. Suddenly there is a slope change of at t is equal to 2. So we'll write t minus 2 here, r, and then what slope change is there? You need to calculate final value minus initial value, minus 2 minus 0, so minus 2 is there, and then it is going on like this, and suddenly slope change is there at t is equal to 4. So r t minus 4 is there, and then there is a slope change. How much? Final value minus initial value, 0 minus of minus 2, it will be plus 2. So there will be like this. So see, you can understand it as this is the expression, mathematical expression for this signal. If you see plus 2 minus 2 0, minus 2 plus 2 0, this is a finite duration signal. So the concept of adding the amplitude is same with the ramp signal also. Now last I think one more question will take, like because this signal is also a mixture of some signals like sawtooth pulse. Okay, so we'll take it as a sawtooth pulse. Sawtooth pulse consists of two signals. Like, see, this is a sawtooth pulse. It contains, like, let's suppose it is from 1 t is equal to 1 to 2, and this pulse consists of both signals. There is a unit ramp signal also. There is a slope change, है ना, at t is equal to 1, and there is a step change also. You can see a sudden step change is there. So sawtooth pulse can be formed by adding two signals, that is ramp and unit step. Okay, so we need to represent also. So let's represent it. See, the signal is coming from minus infinite, and suddenly there is a slope change. So first we need to calculate the slope change. So let's, the magnitude is 1. So slope 1 minus 0, 1 minus 0 by I think 2 minus 1, 2 minus 1, so will be 1 by 1 equal to 1. So there is a plus 1 slope change. So we can write it as rt minus 1, rt minus 1, and slope will be plus 1 only. Okay, so this is going on, going on, going on, going on, going on, and suddenly there is a, at t is equal to 2, ठीक है, after t is equal to 2 there is a zero slope, and before t is equal to 2 there is a slope of plus 1. So ultimately at t is equal to 2, r t minus 2 is, at t is equal to 2 there is a slope change. What slope change? Final value minus initial value, 0 minus 1 is equal to minus 1. So this you can plot, but there is a step change also. You have calculated the slope change, but you have not calculated step change. So step change will be, how much step change? One step change will be there, and how much in negative side? So minus 1 u t minus 2. Okay, so sawtooth pulse can be represented it as a combination of unit ramp and unit step. See, at same time instant t is equal to 2 there is a step change also, and there is a slope change also. So sawtooth waveform has this property also. Okay, so I think this was from this lecture, and we shall take next lecture on what are the effect of time scaling and time reversal on unit step ramp signal and unit impulse signal. So from the, for this lecture this much only. We'll meet in the next lecture. Till then, tata, bye bye, see you, have a good day.